Welcome to ID the Future, a podcast about intelligent design and evolution. Greetings, I'm Andrew McDiarmid. Can an intelligent design theorist work effectively in a naturalistic culture? Today I'm with Paul Nelson, a senior fellow of the Discovery Institute's Center for Science and Culture and adjunct faculty in the Master of Arts program in Science and Religion at Biola University. Nelson is a philosopher of biology who has been involved in the intelligent design debate internationally for 3 decades. Paul, welcome.
Thanks again for having me.
No problem. Well, just to recap for our listeners who may not have heard parts 1 and 2 of this series yet, you first shared some remembrances and lessons learned from one of your academic mentors, philosopher of science Adolf Grünbaum. From there, in part 2, you talked about what it means to be trapped in a naturalistic parabola, that axis of Darwinist reasoning that seems to extend infinitely. What would you like to say about those 2 episodes? Just a quick summary.
Well, over the past decade, I've thought more and more about how an intelligent design thinker can best use his or her time. And it occurred to me that we shouldn't attempt the impossible. If the person we're talking to has a fundamental commitment to naturalism, which I take to mean the view that what's really real out there in nature is physics. So, for instance, if you read the work of Sean Carroll at Caltech, he's very eloquent on this point that notions such as free will or agency ultimately derive bottom up from the bottommost layer of reality, which is physical. There are no minds down there. There's no intention. There are no purposes, goals. All of that derives via long chains of complicated causality, but ultimately those chains run back down to the bottommost level. That's what I understand naturalism to mean. That if you're talking to someone who holds that view, and they hold it as a foundational commitment. So it used to be the case, I don't know if it's still true, that Sean Carroll's personal webpage, he gives naturalism as his worldview, in effect as his religion. That conversation is going to be very frustrating in the long run because evidence is subordinate to a philosophy. So over the past decade, I've thought a lot about this, and I realized I don't want to live in that world, right? I'm arguing with somebody who ultimately is not going to be open to persuasion, and evidence is going to be discounted in light of that philosophy. So how can we best use our time? Well, really, it's to leave what I call the naturalistic parabola. And I cast around for a geometrical figure that would have a starting point. So my naturalistic parabola in the article that I've written about this commences roughly in the mid-19th century, but then it extends infinitely into the future. You don't want to be trapped in there. If you're a design thinker, you want to develop your ideas in a way that is fruitful and that will not condemn you to a fruitless task, which is trying to talk somebody out of a philosophy that they're fundamentally committed to.
And that is a struggle for a lot of folks, but here it seems like you're coming up with some ideas that might help. Well, in our second episode together talking about this, you ended by saying a reason for hope was the third member of the naturalism versus design dialogue. And that actually, the debate was much better described as a trialogue or a 3-way conversation. So don't keep us in suspense. Who is the third member?
It's nature herself. And I do not apologize personifying her, because I think in a very real sense, she talks back to us. So my academic training is in the philosophy of science and evolutionary theory. And the philosophy of science is usually considered a branch of epistemology. Epistemology is the discipline of philosophy which asks, how do we know things, right? And so if the philosophy of science is really the study of how are theories constructed, how do we know when they are in trouble, how do we know facts about nature, it really is genuinely a branch of epistemology. So as a student, I more or less stumbled on one of Ludwig Wittgenstein's late works, written actually as he was dying. He was dying of cancer, 1949, 1950. and was visiting Cornell University and kept a notebook that was later published posthumously with the title Uncertainty. And it's an investigation of epistemology. How do we know? How do we know all kinds of things, but in particular, how do we know scientific facts? How do we know scientific knowledge? And I've gone back to Uncertainty so frequently in my personal library that the binding on my copy of the book broke. So I kind of have to hold it together with a rubber band. And in Uncertainty, towards the end of these notes, Wittgenstein says, and this is the English translation, "It is always by favor of nature that one knows something." So in my edition of the book, the German text is published on the facing page. So you have German text. He wrote originally in German. The German text is on the left-hand side, and on the right-hand side is the English translation. So I can look at the German text, and the word that Wittgenstein uses for favor, so in this statement, it is always by favor of nature that one knows something. The word there is Gnaden, Gnaden. Well, if you look that up, it actually, the number one meaning in English is grace. And actually, it's the same noun that you see in the New Testament. So to verify this, I have a German Bible, I grabbed it off the shelf and looked at the salutation in Corinthians, the first letter to the Corinthians by the Apostle Paul, and sure enough, there it is, by grace. So I actually think that's a better translation. It's the grace of nature. She makes us gifts of her information if we ask her in the right way. And I love that thought that it's by her grace she's making us these gifts of knowledge that we know anything about the world.
Huh. Yeah, I've never heard it put that way before. Well, why is nature herself so important, and how exactly does nature talk back to us?
By experiment. So if you think about what you do when you set up an experiment, you are posing a question to nature. There's no point in doing an experiment if you already know the outcome. I mean, yes, you could do it to teach someone, but presumably they don't know the outcome. So a student in a chemistry class is doing an experiment so that he or she can see what nature is going to tell them. But a scientist working at the cutting edge of knowledge, when he or she sets up an experiment, they're putting a question to nature that could turn out in a number of ways. That's the whole point of doing an experiment, is you eliminate the free variables, you use controls, you set up the situation so that nature will provide you with an answer. And when I personify nature, it's in the sense of Proverbs 8, wisdom, right? Those beautiful passages in Proverbs 8 where wisdom is instructing us, because she was present right at the beginning of the creation, at the very deepest level of physics, all the way up to biology, and is known as the empirical attitude. So if you look at the scientific revolution and the writings of people like Newton or Francis Bacon or Boyle, one of the campaigns they ran was to eliminate the authority of ancient texts like Aristotle. We learned a lot from Aristotle, they say, but he taught us a lot of things that just weren't so. And if we want to understand nature and to control nature in such a way that we can benefit human life, we have to go to nature herself, not to a text, but to nature herself. So this is the empirical attitude, and actually the motto of the Royal Society, which was founded, of course, in the scientific revolution, is nullius in verba, Latin meaning take no one's word for it. Well, if you look at the history of science, science didn't really get up and running until they stopped taking Aristotle's word for it and said, well, you know what? Aristotle's great, but we have to go inquire of nature herself. So in setting up experiments, we give nature the opportunity to talk back to us, and then she instructs us about how she really operates. And it's the empirical attitude that gives science its power.
That's really cool. I like the Royal Society motto. I wish they would remember that sometimes with some of the things they put out. Can you give us an example of how personally you're hoping to hear back from nature in your own research?
Yes. I, as a student, lived through the development of DNA sequencing technology. So when I began studying biology as an undergraduate in the early 1980s, it was very difficult to sequence DNA and proteins. And you can look at the history of protein sequencing, for instance. Frederick Sanger won the Nobel Prize for sequencing insulin, which is a very small hormone. It took him years to work that out. Now, a high school biology class, an AP biology class, if they have an Oxford nanopore sequencer that they can plug right into their laptops, they can get information that would have been unimaginable to Sanger or to Francis Crick during their careers. So I watched these technologies come online in the mid-90s. And one of the things that geneticists realized as they began to do large-scale genomic sequencing was the genetic universe appeared to be very much larger than anyone realized. So put yourself back 1995 or so, 1996, when the first whole genomes are coming in. One of the things that jumped out at people were the number of genes that appeared to be genes. In other words, they had the molecular features that characterized so-called open reading frames, sequences coding for protein. But nobody knew what they were doing, right? These genes did not have matches in the existing databases. So from roughly 1995 to about 2005, there was an open question: where did all these novel genes come from? And they were known by many names: orphan genes, taxonomically restricted genes, de novo genes. So for about a decade, 95 to 2005, the question was, are these things real, right? Now, from 2005 to 2020, that question has been settled. Orphan genes are definitely real because the pattern of their detection has not changed. In fact, it's grown much, much stronger. Now in 2020, the leading question is, where do these orphan genes come from? How do they arise? Okay, this is just a beautiful example of nature talking back, because nobody expected this. Prior to the mid-90s, the leading theory for the origin of novel genes and proteins was you got new genes from old. A gene duplicated, and the original copy was still coding for a protein, performing its function, and then the duplicated copy would be free to mutate and perhaps evolve into something else. Well, in that process of templating, duplication, you carry a signal of history, right? If you look at how the spelling of English words change, they don't change overnight. There's a gradual modification process. Well, this was a case where new words, so to speak, were entering without precedent. That was nature talking back. And the technology of rapid and increasingly inexpensive DNA sequencing enabled the discovery, and nature surprised us. One of the things I love about science is that she does surprise us. She has all kinds of surprises that are still there waiting for us to stumble on them, which makes science just so much fun, to be honest.
And this is something you're still studying, right? The orphan gene.
Yeah, it's an ongoing project. A group of us, it's actually an international collaboration, have been working on what's known as Orphan ID, which is an analytical pipeline for processing genetic information to isolate and characterize the orphans. But then Orphan ID is being built into what we're calling Orphan Base, which will be, if we can get it working, a comprehensive database of known orphan genes. And we're ambitious. We want to get all of them, from viral sequences all the way up to oak trees and starfish and you name it.
Wow. Well, I wish you well with that. Sounds like you've got the technology to move forward with that, and the know-how and the understanding. Any final bits of advice for our listeners as we close this series?
Yes. As long as science is putting questions to nature, and as long as we are listening to what she tells us, we can have hope in the scientific enterprise, because nature is independent of us. That's why testing works. By contrast, once science stops testing and stops putting questions to nature and says, we can build our theories and we can forget about testing, then you should be worried. Because that's what the scientific revolution broke free from, which is authority, building models of nature without asking her if those models were correct. So one of the things that terrifies me about the multiverse, for instance, is some of its advocates, and I have to say, as much as I admire him as a communicator, I have to include Sean Carroll here. Sean Carroll has said, testing is overrated. Falsification as a method of scientific inquiry is overrated. I'm sorry, I don't want to let go of testing, because it's only testing that will tell me if I've made a mistake. Because if I'm building theories and I'm not bringing them back to nature and saying, does this actually work, right? Can you tell me if my model of you, nature, is accurate? Once you give up testing, you're doing something other than science. So as long as we are putting questions to nature, and by we, I mean every curious human being, whether a design advocate or not, putting questions to nature and listening to what she says, we will be okay. When you stop doing that, the scientific enterprise begins to die. But let me end on an optimistic note. I think testing will continue, because I think most scientists want to know if they've made a mistake.
Yeah, I think that's inherent in humanity. We want to know.
Another great thing about science is you can fool yourself, but if someone else is looking over your shoulder, it's a different story to try to fool them, and they're going to check your work.
Yeah. Well, Paul, it's been a pleasure to unpack this topic with you. I really appreciate your clarity of thought and your humble approach to science. Always refreshing. Thanks so much for your time, and I look forward to talking with you again soon.
Yes, me too.
You can read more of Paul's work at evolutionnews.org, including the article that this whole series is based on. Just go to the Writers tab and click on Paul's picture. As always, listen to more episodes at idthefuture.com or on your podcast platform of choice. For ID the Future, I'm Andrew McDiarmid. Thanks for listening.
After Google, what's the most visited site on the internet? YouTube. And through YouTube, more people are hearing the evidence against Darwin than ever before. Last year, the views on our Center for Science and Culture channels increased by over 400%. And in just the past 3 months, our YouTube videos had more than 1.3 million unique viewers. For people around the globe struggling with questions about science and faith, these videos are a lifeline. But we can't throw new lifelines without your help. New videos require new funding, and you can help right now by donating online at discovery.org/video2020. Go to discovery.org/video2020 to help fund new films about the evidence for design. And through July 31st, if you give $50 or more, we'll send you a secret preview for the next episode of Science Uprising. Give now at discovery.org/video2020. That's discovery.org/video2020.
This program was recorded by Discovery Institute's Center for Science and Culture. ID the Future is copyright Discovery Institute. For more information, visit intelligentdesign.org and idthefuture.com.